Hello. So today I'm going to do a quick walkthrough of the CAPZ resources for networking. The goal is to ultimately turn this into a document and help like new users and new contributors to the project on board. We used to have this design document a while back as part of the V1 Alpha 2 work, but a lot of it is outdated, so we actually removed it in V1 Alpha 3 because it was more confusing than it was really helping. But some of it is still accurate, so we're going to try to take some of that and update it with what's new in today's resources. So keep in mind that whatever I cover is the state of the world today, which is February 11th, 2021. So some of this stuff will change probably in the future, especially as we're going into V1 Alpha 4 right now. We might change some of this stuff, but I expect the overall structure will remain the same. So I have clusters that I've deployed in different configurations. So we're going to look at the default one first, which is this one, CR27. So this is the cluster that was deployed by the end-to-end test using the default flavor. It has 3 control planes and 2 worker nodes, and it has a standard default API server configuration with a public load balancer, which means it's publicly exposed to the internet. So I'm going to use the network watcher feature or service in Azure, which it's pretty convenient for getting kind of a diagram of what your network resources look like in a given resource group. So if I go into topology here, I'm going to select my resource group that I was just looking at, and it's going to show me all the network resources that I have in that resource group. So for each cluster, we create a VNet, so 1 VNet per cluster by default. You can also choose to bring your own VNet with CAPZ, which means you can have a pre-existing VNet, and you specify that in the Azure cluster. You specify the Azure VNet details in the Azure cluster resource in the spec, and that means CAPZ won't try to create a VNet for your cluster. It also won't delete your existing VNet. When you delete your cluster, that VNet's lifecycle is managed completely out of band. We also create subnets in that VNet. So we have 2. We have 1 for the control planes and 1 for the nodes right now. This is the default in V1 Alpha 3. Things might change a little bit on that front in V1 Alpha 4 because we're going to start supporting more than 1 VNet for nodes probably, and so you might have the possibility to specify multiple subnets. Sorry, not multiple VNets, multiple subnets for each 1 subnet for each machine deployment, for example. If you bring your own VNet, you also have to bring your subnet. So if you bring the VNet, you have to bring the VNet, the subnets, and everything as part of the subnet definition. So that's the network security groups and the route tables. If you don't bring your own VNet, we'll create 1 subnet for the control planes and 1 network security group. And then we'll also create a network security group for the node subnet and a route table. So all of this, the VNet, the subnets, and the network security groups, that's all reconciled as part of the Azure cluster controller, the Azure cluster reconciler, which hasn't changed. It's just that it used to be called cluster actuator. But yeah, this is the same thing so far that what we've covered. You have 1 virtual network, 2 subnets, control plane and nodes, 2 network security groups, control plane and node, and then 1 route table for the nodes. Hey, Scott. I'm just going through it, so I'm just going to keep going. But if you have any questions, let me know. So far, I'm just looking at the topology of the default resource group in Azure. And so I was just covering what you get if you don't bring your own VNet, and then versus if you do bring your own VNet. Okay, so then this is the part where things changed a little bit in the load balancer land. So for public clusters, you get one public load balancer for your control planes. And that public load balancer has a public IP. So that's something that I've seen people kind of get confused about recently is your control plane nodes do not have a public IP each. So each VM in your cluster has a private IP, but your load balancer, the public load balancer, has a public IP. So you share one public IP for your whole cluster. You don't have several public IPs for each node. And then you have inbound NAT rules, which allow you to SSH to the control planes through the load balancer. What else? Yeah, so there used to be an internal load balancer that was defined. We don't have that anymore because it wasn't being used. So there's an external load balancer for the control planes. And then for your, in Azure, you can only have one load balancer attached, one public load balancer and one private load balancer attached to a VM. You can't have more than one public load balancer attached for a VM, for example. And so that's kind of the reason why we have this outbound load balancer that gets created for the worker VMs, kind of multi-purpose. So this public load balancer right here is attached to the worker nodes, the worker VMs. And it actually has two purposes. The first one is to give outbound connectivity to the nodes, and that's enabled via the outbound rules. And the second one is to, it's used by a cloud provider, the Azure cloud provider. When you expose a public service, that's the load balancer that gets the LB rules necessary to expose that service. So we created, CAPZ manages its lifecycle. So, but cloud provider also modifies it throughout the life of your Kubernetes cluster. And then we have internal load balancer here. That actually wasn't created by CAPZ, that was created by cloud provider. So this cluster has an internal service and an external service exposed that run as part of end-to-end. And so that created the internal load balancer that you see here, but we don't create that or manage that as part of CAPZ controllers. Any questions about this stuff? Okay, let me go back to... So this covers the, this covers what everything that's reconciled by the cluster controllers. So load balancers, public IP, route table, network security group subnets for VNets. Then you also have like network interfaces. Those are actually, oh, that's the subnet. But the network interfaces are actually reconciled by the machine controller because you have one per machine. So the network interfaces lifecycle is tied to the machine lifecycle. I want to look at, so this is for like a classic default flavor cluster with virtual machines using the Azure Machine resource. If you use Azure Machine Pool, which creates VMSS, you'll get a slightly different configuration. And that's because the scale sets in Azure, they don't have a separate network interface that gets created. The network interface is actually like part of the scale sets. So that's just a slight difference in the machine controller. We don't have to worry about reconciling the network interface for VMSS, but otherwise everything is about the same. And then the other configuration that I wanted to cover, which I need to find which resource group it is first. But in the case of a private cluster, which is done by setting the API server load balancer type to internal, you get a bit of a different configuration. I actually don't know if I have one here. No. Okay. So in the case of a, let me go back to the network watcher. So in the case of a private cluster, you get, you don't get, also, sorry. So your API server load balancer will be private. So it won't be that public load balancer here. It will be a private load balancer. But you actually still do get a public load balancer for your control plane nodes. And the reason for that is it's a requirement in order to give outbound connectivity. So not inbound, outbound from the control plane VMs. You need that external facing load balancer with a public IP associated to it. So you still get a public IP and external load balancer. It's just that it doesn't have any inbound load balancing rules. So your control planes aren't actually accessible from the outside, but you still need that for outbound connectivity. And then on top of that, you'll get an internal load balancer for your control planes, which is for inbound load balancing rules. And so that means your control planes will only be accessible from within that virtual network or within a peered virtual network. And then in terms of the worker nodes, it will all be the same because your worker nodes already don't have like public inbound rules. So they'll have a public load balancer with for outbound connectivity and for public services, and then you'll have an inbound load balancer that gets created by cloud provider if you expose an internal service. Hey Scott, do you have any questions or anything that you think it would be interesting to cover? I'm kind of improvising here.
No, it seems very clear to me. Really good explanation of the different topologies. What is the need for the outbound from the control plane? Is it possible to turn that off, or is that going to be necessary in all cases?
That's a good question. Yeah.
With the machines that do have all of the images pre-baked into them from Image Builder, yeah, would there be a need?
Yeah, that's a great question. It's not always needed. No, you could actually, in some environments, you actually don't want to have outbound, and some environments can't have outbound access. Like if you have like a locked in environment scenario where you can't access the internet from your virtual machines, and that's actually a case that we'd want to support eventually. But the default case, I think we want to give you outbound connectivity in case you need to download extra packages or do things on the virtual machines, like after the VM is created.
Okay, so that's not possible today, but it is something that's planned for the future.
Right, exactly.
Okay, sounds good.
So yeah, I'm hoping this video, you missed the beginning, but I kind of went through the purpose and why I was doing this, but I'm hoping that this helps with this issue, which is the goal is to turn this into like a documentation. This was the old one that we had, which isn't super accurate anymore, so just want to refresh that. And I know that the networking resources are one of the most confusing aspects of CAPZ, so a lot of people ask questions about it, so I'm hoping it can help newcomers to the project.
Definitely, and hopefully other providers will also learn from this, because it definitely is something that's difficult today in the different cloud providers and not well documented.
Yeah.
So definitely hope that this brings it forwards. And it was very clear explanations. And so thank you.
Thanks. I recorded this, so I will watch it and make sure it's all good, and then I'll post it on YouTube and share the link on Slack. And then I'm also happy to answer any follow-up questions. Like if you're watching this recording and something wasn't clear, or if you have a question, feel free to add me on Slack and I can try to clarify. All right.
Awesome.
Thanks for coming and asking a question, Scott. And if you have any questions, let me know.
Great, thanks.